This chapter is on the laws, like law of sine, law of cosine, area problems, force vectors, and some ambiguous case stuff. Right? And make sure on the reference sheet you guys get all the formulas, except please make sure these are general formulas. So you don't want to be concerned with the A, B's, and C's. You want to think about more like the place of your formulas. I know that came up on one of our Regents exams, right? The A doesn't mean angle A for all the problems, or you have to look at the spot instead. So let's start with the kind of easy one, area. Okay. They like to do area of triangles and parallelograms. So if you guys have the triangle-shaped pool, I measure 16 feet and 21 feet. All right. So we make ourselves a picture. 16 and 21. Does anybody know what it means by included angle? Good, where they connect. Nice job. It's 58. They want to know what is the area to the nearest 10th square foot. Okay. Now, when it says the area, that's what you guys want to use this for. It's going to tell you find the area. So you're going to use K equals 1/2 AB sine C. Right, again, this is just general, so we want to make sure the sine is always connected with the angle. So what's the only angle you guys have? 58. Good, so we're starting sine 58. Okay. Now the A and B are always going to be the two sides that form the angle. So 16 times 21 times an F. All right, and you literally just plug this all in. Make sure your calculator's in degree mode. Do a good check. I was not. So. Right now it's better now. Okay, so I have 0.5 times 16 times 1 times sine 58. Anyone here is what is it? 142.5? Is that right? I don't even know like what problem maybe. I restarted it. Alright, so that would be that. What do you guys think was the area? Good. Okay, if you're doing area of a parallelogram, what do you have to do? Times it by 2, or what else did you decide timing it by 2? Get rid of the 1/2. Get rid of the 1/2. Good. Okay, either one you personally like. Either get rid of the 1/2 or just times your answer by 2. Now this one is, actually, you know what? Let's go backwards. Let's do 3, and then we'll do 2. Right, because 2 is a little trickier. I'd rather do 3 first. Alright, so this one's triangle ABC. Okay, so you guys draw your triangle. Okay, A is 33. Okay, the little a is 12. Make sure sides and angles are across from each other. A lot of us mess that part up when you guys are drawing your pictures. Okay. Little b is sitting across from angle B. Okay. They want to know what is B. Okay. Anybody know what law would you guys use for this one? Sine. Good job. There are law of sines when you have two sides and two angles that are partners together. So 15 is going to go with X. 12 goes with 33. And again, they give you guys a formula up here, but you're only ever using 2 of these. They write it all of them, but you're only ever using 2. So when we set it up, 12 over the sine of 33 equals 15 over the sine of X. Then do your cross multiplying. 15 sine 33 equals 12 sine X. Okay, divided by 12. Now, when you guys are trying to separate sine from X, what key do you have to hit? Second function. Good. So type this all in first. 15 times sine 33. And then divide it by 12. Second sine. Put that on the term. Oh, geez, I did a negative sign. There we go. Okay, so that's 43 degrees. How is everybody putting that in? Good, bad? Oh, yeah. Alright, let's go back to number 2 now. So, 3, this is pretty easy, really general kind of sign question, right? Example 2 is tougher because of the way it's written and what they give you, okay? So here, they ask you guys what length A is, okay? Do they give you what angle A and what angle B are? No, they just give you the sign of A. So with this problem, if you guys started to draw your triangle, A, B, and C, well, I don't know what A is. I know that little b is 20. I don't know little a. How would we do this? Anybody have an idea? You can't use SOHCAHTOA or A squared plus B squared and C squared because that's only if you have a right triangle. Here we got it. Okay. She said that you should just put in, you know what sine A is, so put it right into the formula as what it actually equals. Good job, Zoe. Alright. So when you guys look at your formula, the formula looks like this. A over sine A equals B over sine B, right? Well, we're looking for A. We don't know what this is. So A should stay A. But what can we replace sine A with? 1/4. Good. Okay, this whole thing is 1/4. They give us B? Yeah, it's 20. And so now this is 20. And sine B, we're going to get rid of that whole thing. And it's just 1/8. Okay. Now, do you guys have any signs left at all? No. Okay, so this is just going to be cross multiplying with straight cross multiplication. Right? They already did the sign work for you guys. So when you guys just cross multiply, no, because it's giving you that sine A is this whole thing. So it already has included the sign with it. So this is like 1/8 A. 4 times, or 1/4 of 20 is 5. How do you separate from a, divide by 1/8, or what else could you do? Good job, Lily. Multiply by the reciprocal. Very nice. Okay, good. So 8 equals 40. Right. I threw this one on because, again, like your Regents usually they're like this. I mean, you might not even see one crazy like this, but just so at least you have maybe seen it before. Okay, kind of one way to get to it. Alright, let's try this next one. And why don't you guys draw yourself a picture, see what you got? Anybody know what law you should be using? Cosine, so because you have 1, 2, 3 sides and only one angle. That's kind of your clue. Now remember, when you do your law of cosines, you have to be very careful with how you sub things in. Okay, you get the formula way up at the top. Okay, but remember, the A isn't just A in here. You have to be careful where they fall in the triangle. So we're going to start with the cosine of the degree. Okay, so the cosine of 120. Now, what's across in the triangle goes across in the equal sign. So way over here, what should you guys have? X squared, okay? This caused a lot of issues in the last little Regents. You guys got this one wrong, right? So just be careful. You're not following the formula. You're following the outline of the formula, but you have to be careful where you place things. Now, the other two sides you didn't use, those are like the B's and C's in the formula. So we'll have 6 squared plus 10 squared minus 2 times 6 times 10 cos 120. Right, can you enter this all at one time? Look at it, what's going on over here? Yeah, because there's no x's. So let's enter this all at one time. And I would do it all at one time, right in your calculator, so that you don't mess up forgetting a sign. pull x squared, right? What do you have to do at the end? Square root it. Good job. 14. Okay. Alright. Since we're on cosine, let's see about this next one. Why don't you guys try to draw your picture? See if you can set some stuff up in here. Are these good at like sides and angles are across from each other? I know, it's okay. Take a second and make sure you guys are okay with what where you plug things in. Okay. Go for your plug if you don't have Ashley. Right. And you can't do both X and you don't have X. Right. It's just going on in the first cell. So what we want to do is go to X. Okay. So cross on the triangle, or cross on the equal thing. So she's cross for a minute. Alright, good. Looks like we're doing a good job with our make sure you start cos x, right? Because across from the triangle goes across the equal sign. So way over here needs to be your 12 squared. And we should have 10 squared plus 14 squared minus 2 times 10 times 14 cos x. Can you just put this one in all at once? Yeah, this is where you have to use your chunking stuff. So we got to chunk stuff together. Okay, so 12 squared is going to be 144. What did you guys get for your 10 squared plus 14 squared? 296. Good. What about the next one? Okay, so wait, that's going to be 280. You got 280? What did you get? 280? Right, 280. Oh, yeah, you can't put the cosine with it. Right, because you don't have a cosine of anything, like there's an X there, so you can't be together. Alright, now watch out. You guys did this part good. Be careful that you're not subtracting these, because are they like terms? No. So you have to get cos x rules when we move everything across. So we're going to minus 296. So 144 minus your 296. And jump. What did you get, Andrew? Negative 152 equals negative 280. And then again here, how do you separate? By the negative, right? Good job. So cos negative 152 divided by negative 2. Never remember. Yes, there we go. Alright, and then you guys have to hit second cosine, and then put your answer in. Remember, missing a degree, so you have to use that second function key. Should we get 57? Right, watch out for the starting spots. That was where I saw like the biggest issues. It looks like most of us kind of addressed those. Do you remember the starting now, like cross and triangle, cross and triangle? This is 7 degrees. Okay, good work. Alright, you're gonna have probably one problem somewhere where you guys have to do that. This has come up too on one of the Regents exams. I think actually both, right? The two that we've done so far, they've had something about like how many triangles exist, Or is the triangle a Q, obtuse, or both, or neither? Right? So this is a pretty big thing called the ambiguous case. Now, when you guys look to start this, right, it's always about a triangle, and if you fill everything in, the A, B, well, we don't know what C is, it's fine, but A is 30, right, little b is 8, little a is 5. Where would you have to put the X? Angle B in the dash line. Okay, so your first job here, when they're talking about like how many triangles can be made, or is the triangle Q or obtuse, find out what that little angle is. What law would you guys have to use? Sine. So then you're actually always going to be using law signs with this. Okay? So like 5 over sine 30 feet over sine x. Okay? We're going to do that cross multiplying. Let me know what you guys get first. Okay, there you go. That's just because it's so small, it looks weird. Okay, good. So I saw when you guys did your first answer, you got 53, right? Now, so one of these triangles works. If you put 53 in here, are you over 180? No, so this is good. One triangle works, and 53 is acute, so that would be an acute triangle. Now, the other thing you can test with this is where sine's positive, the first and the second quadrant. So the other value you want to test is always going to be 180 minus your degree value. So if you take 180 minus 53, 127, good. So now 127 is obtuse, right? So if we take 127 and you put it in the same spot for that X, can I do 127 and 30? Right? Yeah, you're not over 180, right? So this means that two triangles work. That it could be obtuse or acute. It could be both. Yeah.
If I want to select the first decimal place,
So that was really okay. With these ambiguous case questions, you could do nearest like 10, you could do a whole number, it won't throw you off. Right? If you guys got a 0, that means you would have had an error right in the very beginning. It's never going to be 3. Okay, 3 is in there just for another multiple choice. This is never will be 3. Moving on. Alright, force vectors. These don't come up a lot, but when they do come up, if you don't know them, and you're kind of screwed. Yeah. Alright, so with force and vector problems, what we want to do is kind of use the properties of a parallelogram. So we made our two forces, right, like force 1 and force 2. And you only want to do this. I saw like people drawing like this type of picture for almost everything. Sometimes they said it was a triangle when we were drawing this. So make sure you guys read. You're only going to make yourself this force vector parallelogram idea if you're saying like, what is the force? What is the magnitude of the forces? You're going to see something in the problem about forces. Okay, if you don't see anything, don't draw this. So in a parallelogram, right, a couple things we have to know. What do you know about your opposite sides? Congruent. Good job. Nice. So these are congruent. The other big thing is that consecutive angles in a parallelogram add to be 180 degrees. So this angle plus the top angle, those equal 180. That's always the starting spot with these force vector problems. Right? And the angle between, right, does not get bisected by the resultant, so you can't say that these two little angles are equal unless the two forces were exactly the same. It's the only time it bisects. let's see here, what we got, we'll draw a picture. So tractor stuck in the mud is being pulled out by two trucks. One truck applies a force of 1,200 pounds, the other truck is 1,700 pounds. The angle between the two forces is 72. Find the magnitude of the resultant. Alright. So right in here, you guys see the words like forces, alright, resultant. That's the only time we should be drawing those crazy color parallelograms. Okay? Not for everything else. So, can somebody tell me what one force is? Good. One force is 1,200. I like it. So that's going to be like my force 1. Okay. And then what's the other one? 17. Perfect. Force 2. Okay. So those are your two forces. Now, what does it say the angle between them is? 72. So this is 72. Okay. They ask you guys to find the magnitude of the resultant force. So the resultant is that line. Okay. We don't know what this is. Can I say that this is like 36 and 36? No, because the two forces are not the same, okay? So what we're going to do is use our properties of a parallelogram, right? We're going to kind of make a connection out of it. If you know the bottom is 1,700, what's the top? 1,700, good. Left side is 1,200, right side 1,200, okay. We can't use the 72 degrees because it's getting cut. See how it's getting chopped somehow? You don't know how it's getting cut, so we can't use 72 degrees. But they give you guys this to find the top. What do your two angles have to add up to be? 180. So this is always one of the biggest steps in force vector problems, right? They like to give you the bottom and make you realize that you need to get the top. So you know that you have to add it and get to 180 by taking 180 minus 72. 108, right? That's going to be your top angle. And that angle is not getting cut by anything. Yeah, Ashley?
So say it's like they have this percentage at the bottom and it has like 32 and 32.
So they gave you that this is like these were
Yeah,
something?
they were both 32.
Okay.
Would you just subtract 32 from 180 to get that angle?
You'd have to do like 32 plus 32.
Okay.
And then subtract that from 180. I'll be right over. Oh, thanks. Thank you.
Oh.
So you have to subtract the entire bottom and both of those combined. Does that make sense?
Yeah.
Good. All right. So what you guys are going to take out the part that you're dealing with. Okay. Right. This is your x. This is your 1,200, 1,700. This is 108. Is this little piece 72? No. Okay. Because when you take it out, that's just this top part of the triangle. So we don't know what that is. It's not 72 though. We just don't know what it is. Right. Law of cosine? Okay. When you guys see these force vector problems, you're going to use law of sines or law of cosine to solve them. Usually it's law of cosine. Okay, so you got 1, 2, 3 sides and only one angle. Be very careful, especially when you're doing a law of cosines with these huge numbers, because it's really easy to mess it up in the calculator. What are you going to start with? The cosine of which angle? 108. Good. What's going to go on the other side? X squared. Very nice, you guys. Good job. All right. Perfect. And this is a nice one. Can you put this one all in at once? Yeah, there's no X's over there, so go for it. Put it all in at one time. Give your calculator a double check though, because you're relying totally on the calculator here. Alright, when you guys do your square root, 2, 3, 6 works? Yeah? Does that work now?
Yeah.
Alright, last one I got for you guys. It's not hard, but I see people missing a lot of steps. Okay. Okay, so this was an example of a 6-point question I saw from the old math speed test. A part 4, 6 points, but it's the same stuff as what you guys do. So this could definitely be one for what you guys see. So take a second, read it carefully, and we have to decide what we need to do here. So that's a good start. Now, what did they ask you guys to find? The area. Good. So it tells you right in here, find the area. So I have to ask K equals 1/2 AB sine of C. Alright, well, if we try to do that, does anybody see a problem? Yeah, you don't know an angle. So can we do this? Lily's got it. Fantastic. Oh, I didn't hear you. All right. You guys don't know you don't know a value of any degree, so what we need to do is find a degree in here. For the sake of us all kind of doing this together, technically, you guys could use any angle in here, right? But you just need some degree. So we get the same answers as we're going through. What angle do you guys want to find? See? Okay, that works. All right. So now we can figure out what that angle C is by using which law, though? Cosines. Good. All right. So set up your law of cosines. And here, I'll help you set up your law of cosines. What are you going to take the cosine of?
No, I'm done.
X. Good. What should go on the opposite side? 5 squared. Good job. Perfect. Again, please be careful with these huge numbers that we're solving them. When you go to solve it, you have to use the chunky. Your voice is like this thing.
What are you trying to find material? Yeah. Okay. So why did you lost on this?
Wait, look up there though. Do you have an angle to use? Oh, okay, yeah, you're right.
I always do this.
Yeah, no, you're welcome. You would have to have an angle to do that. One of the other angles. Oh, right. Good job. This is great. This is good. I totally did not even understand how to do the first out.
You did two imaginary problems last night.
I can draw this and get my angle. This one and this one. ED. It's ED and it's TH. You do this one. The ED is like this. Yeah, good job. I can draw one right. I would keep it out a little bit. Because that's not your final answer, right? You're gonna use that, so just be careful. Yeah. Okay, let's see what we're getting here. When you guys did your chunking, what'd you get for your value of x? 49 point something? Okay, now be careful with this, because when we did the law, one of your law application tests, what'd you, oh, 0.25? Sorry, thank you. Okay. Just be careful, this is not your final answer, right? You're using it to still get to the final answer, so don't round too much. So let's put this as your 49.25. Now, when you guys go to do your area, okay, this is really important. What two sides do you need to use? What do the A's and B's have to be?
That are enclosing.
Enclosing it, good. Right. The A and B guys have to be the two sides that form the angle. So when you type this in, it has to be 135 times 160 times the sine of 49.25. Okay. Once you guys type that one in, see what you get. Oh, you don't need to do that? No, that's good. Alright, once you have an angle, you don't have to find the area. You just have to find it quickly, so then you can get the area. You don't have to do all that. Oh, that's fine.
Okay.
Okay. Which angle do you want to use? Because you can use any. You want to use that one? Okay.
No, I want to use that.
Alright. So now, just to know, if you need a second, if you wait, alright, if you're going to use this angle though.
Oh, yeah, yeah.
No, you have to use the two sides that form the angle. So you would actually have to use this one, this one. No, you're good.
So it means you drop down to 8200.
This is your angle that you got, right?
It's not 100, it's 100.
The two sides. You have to use these two. So I'm going to talk to you guys about rounding.
Wait, why is it 100? That's 100. Like go 82. That'd be like 82.
Oh, okay. You're like a little bit off. Just try to make it harder than you want. Oh yeah, okay, so don't round it. No, so you're like a decimal off.
Wait,
All right.
why is it rounded to the 100, not the 200?
So it's because it's
Oh,
being
yes.
You get this 0.0000.
Wait, what did you use for your A&B value?
And then you plug it in.
So one time, you did the one. Oh, it's fine. You're forming a sine. The area. Okay, and then there you go. Okay. Now, when you guys did this real quick, you got 81. Was it 80 point?
Wait, I got 81.
Yours is gonna be different.
No, like I just.
I know. This part for you is gonna be different.
No, I did that.
Oh, you did
I
it.
did that.
Okay. You want the 81? Okay. And then, what was your decimal?
0.1831.
Okay.
I just used the whole.
Alright, now watch out for this. Okay, they love to do this weird stuff. Okay, make sure you read. They want to the nearest hundred, EV. Okay, this is hundredth with like a TH. Hundred is this. So is this closer to 100 or 200? 200. So 8,200 would be the area.
Yeah.
Okay. I think you guys could get stuff like this, right, where there's really small data set, maybe you do two things.
Yep.